All right, guys, I wanted to do a video on proportional relationships, and you can see that I've added some animations into my videos. You can see my sweet breakdancing here on this title slide. And what we're going to be doing today is reviewing the concepts that we've covered thus far in math with proportional relationships. We have talked about what they look like on ratio tables. We've also talked about what they look like on graphs, and even introduced what proportional relationships look like when they're written as equations. So those three pieces are really important. We're going to use that today in this quick math lesson to talk about this setting here with our hiker and our little mountain goat friend, and come up with get some information about this hike that this person is going to go on. So we're going to let this person start hiking here and gain some knowledge as they're hiking. So we can see the mountain goat and our hiker's heading up, trying to keep that even pace going up. She eventually stops and looks at her map and notices she's traveled 7 miles in 2 hours. Okay. Continues up, heading towards the top of the mountain now, getting very close to the summit, and finally reaches the top and looks down at her watch and notices that she's traveled 4 hours for that fantastic hike. Such an amazing experience to the top of this 14er, and is safely heading back home here. So quite an experience, but let's take that information and gain a little bit more information about this hike. So we're going over and we're talking about the rate that this person was traveling at. We noticed that they traveled 7 miles in 2 hours. Okay. And the other bit of information that we have is that at the very top, she looked at her watch and she noticed that she had traveled a total elapsed time of 4 hours. So my question for you is, given that she was moving at a pretty even rate, what would you expect that distance to be all the way to the top of that mountain? Any ideas? One thing that I'm starting to see here proportionally is that our 2 hours can be scaled up to 4 hours by just multiplying by 2. So let's do the same thing with our miles. 7 times 2 is going to give us 14 miles. We would expect that that would be about a 14-mile trip to the top of that mountain. Okay, so that's important to know about this hike. Okay, but I also want to know what rate, what unit rate, what was her miles per 1 hour? What was her unit rate? When we talk about a unit rate, we're talking about a value of 1 for our x, which is hours. So we want to get this down to what is that rate per 1 hour? And you can kind of see that 1 tucked in the corner there. Okay. Well, how do we go from 2 hours down to 1 hour? Well, that's just taking 2 and dividing it by 2, right? So let's do the same thing with our miles. And 7 divided by 2 can seem like that's going to be difficult, but it's really not too bad. If you think of 7 as simply 6 plus 1, 6 is very easy to divide by 2. That's 3, in this case, 3 miles. And then 1 divided by 2 is going to be 0.5. So we end up with 3.5 miles per hour as her unit rate. Well, let's go and take this even one step further. Okay, let's talk about this on a graph. As you can see on this graph here, I've plotted those hours. We have that 1 mile at, or 1 hour at 3.5 miles, and the x values are our hours. The y values are our miles. So 1 hour, she traveled 3.5 miles. That was our unit rate, identified right here at 1 hour, or 1 on the x-axis. 2 hours, she had traveled 7 miles. In 4 hours, she had traveled 14 miles is what we came up with. Okay, and I'm going to take this and write out what would our equation be. We've talked about the table that we see in the top. The equation for a proportional relationship is written in the format of y equals kx, where y are values, in this case, miles. These are the miles that we're traveling. The X is the values that we're getting for hours. And K is our constant of proportionality, okay? And a constant of proportionality is just simply, let's see if I can highlight this. Our constant proportionality is just a fancy way of saying that we're looking at our unit rate, okay? So our unit rate here is 3.5 miles in 1 hour. That's our unit rate, okay? And I want to use that unit rate to help us create our equation for how our hiker was traveling when she was out in our Colorado mountains. So what we would do is just take that unit rate, 3.5 to 1, and put it in for our K, our constant of proportionality, okay? So our equation, once we put that in, we could put 3.5 over 1, but we really know that 3.5 over 1, 3.5, in other words, divided by 1 is just 3.5. So I'm going to write that in as 3.5 and stretch this out a little bit. 3.5, and make sure everything fits in there. And here's our constant of proportionality, okay, which is our unit rate. Okay, and that's 3.5 times x. So y equals 3.5x. So what does that mean? Well, let's say she travels for 1 hour, which we see right here, right? Well, 1 hour goes in for x because the hours are our x values. 1 times 3.5 means that in that 1 hour, she would have made 3.5 miles. Let's say she travels for 2 hours. Okay, 3.5 times 2, we put the 2 in for x. We put that number right here directly in for x. 2 times 3.5, that's 7 miles. What if she travels for 3 hours? Okay, we put in the 3 hours because hours are our x values. And we put it in for x. 3 times 3.5, okay, that's going to give us 10.5 for the number of miles, and 4 and 5 and 6, and so on. So we can use this equation to figure out whatever hours we want to in the distance that would come out to be at that rate, or vice versa. If we have a mileage and we want to figure out how many hours it's going to take to travel at that mileage, we can also use this equation by putting in values for y. So hopefully that is helpful and you guys get a little bit more understanding of unit rates and how they look on a graph, that line that we see there, that straight line, also that they are traveling through that 0, 0 point, okay, right there on graphs, okay, how they look on a table, and how they look in an equation. All right. If you do have any questions on that, please ask. I'd be happy to go over some of this information with you. Thanks so much, guys. I will let you go end of our review. Thanks.